Hello, we are going to review some very basic information on statistics that I would like for you to know before walking in the door. So, let's see. Okay, so you have received this. We went over this in applied research. And Dr. Weimer's made this, and it's a wonderful way to conceptualize how many of these things fit in the context of statistics. So in previous videos, we've talked about descriptive statistics. These are things that we do just to describe the data we have. We are not worried about generalizing to a population from our sample. We're just describing the sample, the data that we have. Now, in inferential statistics, we are making inferences from our small set of sample we have to the broader population from which we got the sample from. And so those are inferential statistics. I'd like you to see the big picture, that there's a difference between tests of comparison or tests of differences, which are these, and then tests of relationships. And I like to bring on correlation over here too. We'll borrow them, bring them over here. So at the intensive, I would like for you to be able to apply your knowledge for all of these things. You have read about this in the Hatcher book, and I would like for you to be able to calculate simple means, variance, and standard deviations, and just we've talked about this in a previous video. All right, moving on. These are tests of comparison. I encourage you to get out a piece of paper or type notes or make index cards as we go through here so that you can learn these concepts and study them. So a one sample t-test is easy to remember because, hey, the word one sample is there, and that means we have just one bucket, one group of people we're looking at. So these might be specific scores for an achievement test. And let's say that this is my sample, and I want to compare this to maybe a national average. And so I might not have the entire data set for the national average, but by looking at the internet or looking at the article, I might find, hey, the mean was 76. And so given that information, I can compute a one sample t-test. This could be very useful, like if you wanted to see how your district scores do and how they compare to the state average. If you could find the state mean, you can compare your data set of scores to a state set of scores, or to a state given mean, okay? So that is a one sample t-test. An independent t-test is when you are comparing the means between two different groups. You're comparing the means between two unrelated groups. The kids in this bucket are completely different from the kids in this bucket, okay? So when looking at participants in schools, we may be comparing the kids who got their reading intervention and the kids who did not. Or maybe we're looking at the girls versus the boys. Or maybe we're looking at the people who received the after-school instruction and the ones who did not. So that's an independent t-test. You would have in your data set the means between these groups, and it's going to tell you if there is statistically significant difference between these means. Simple independent t-test. Now a dependent t-test is different. It's when we compare the means of two related groups. All right, these are two related groups. And so we have my students here, and I'm going to see how they did on test 1 at the beginning of the year compared to test 2 at the end of the year. I am not going to calculate mean differences here. No, no, no. We learned in Gall and Bork that that is not what you do. In this instance, we are comparing pre-test versus post-test, and a dependent t-test will tell us if there is a difference between the means of these two related groups. They are related because by each student, I have them tied, like this is tied to test 2. Test 1 is tied to test 2. So sometimes you will see this called a paired t-test, okay? And the independent t-test is sometimes called an unpaired t-test. These are completely different groups of kiddos. Now, an ANOVA is called an analysis of variance, and we are going to be looking at comparing the means among 2 or more groups. Now, if you have 2 groups, you're really going to pretty much do a t-test, but you could do an ANOVA if you really wanted to. But usually it's for 3 or more groups. And again, for a simple one-way ANOVA, plain old ANOVA, we are looking at different groups of people. And so this might be different grade levels or different types of programs that they go through. So this would be comparing different types of maybe educational background in teachers. So we could look at those teachers with a doctorate, master's degree, and bachelor's degree, and what's inside the buckets, the scores on something. So maybe we're measuring their effectiveness scores. All right, so this might be what it looks like just in your brain, like, you know, how do we process this? So our independent variables would be the groups. You've got to understand that. The groups, the buckets, are the independent variables. So we're comparing scores, maybe effectiveness scores or achievement scores across the groups. A factorial ANOVA is sometimes called an N-way ANOVA. What this does is it compares the means across 2 or more independent variables. I'll say that again. It compares the means across 2 or more independent variables. So here we have the independent variable of grade level, but we also have another independent variable of gender. And so what a factorial ANOVA will do is it will tell me, hey, is there a difference between the mean scores across grade levels? Is there a difference in the mean scores across gender? And is there an interaction of gender and grade level? So maybe like there's no differences in grade level unless you're a boy. If you're a 7th grade boy, something's going on with anxiety here. Or unless you're a 6th grade girl, there is an interaction. And so a factorial ANOVA will show you where the interaction is between 2 independent variables among the dependent variable, which is usually some type of score or measurement. Now, a MANOVA is a multi-analysis of variance. And what this is when you have at least one independent variable, but you have multiple dependent variables. So the independent variable here would be treatment. Did they get an intervention? Did they go to mindfulness training or not? Okay, so that is the independent variable. But we're going to measure multiple things: anxiety, resilience, and achievement. And so you might be asking, well, why not just do a bunch of little t-tests? And to be honest with you, that's really what most people do. They do a t-test for anxiety between 2 groups. They do a independent t-test for resilience between 2 groups. An independent t-test for achievement between 2 groups, okay? There are different types of assumptions. There's a little more things involved with MANOVA. We might get to talk about that later. But overall, it's when we have one independent variable, but multiple dependent variables. Now we're going to bridge over into the world of relationships. Now, for now, this is all I want you to know. Pearson R, regression, or multiple regression. Now, for Pearson R, we will often see R equals something. And what this does is shows us the strength of a relationship. Okay, so let me skip that. So as height goes up, weight goes up. If the R value was R.70, that is a pretty strong relationship. That yes, indeed, as height goes up, weight goes up. As sugar intake increases, weight increases. Maybe the R value there is more like a 0.50. There's still a relationship there, but maybe it's not quite as strong. And then sometimes you'll see negative numbers. So it might be as absences go up, grades go down. This is a negative relationship. So if we have an R value of a negative 0.70, that is a strong negative relationship. Okay, so just understand Pearson R measures relationships between two continuous variables. Notice we have no buckets involved. There are no comparisons of anything. We are literally looking at, as one thing increases, does the other increase? So, you know, as a person's husband's age increases, we can also see that the wife's age increases, and that makes sense. All right, so the closer it is to a 1, the stronger the relationship is. That's Pearson R. Now let's talk about regression. I want you to know simple linear regression and multiple regression. In the Hatcher text, you'll notice that he calls independent variables predictor variables. And that really is the best term, especially in regression models. And he calls dependent variables criterion variables. So what this is it takes the level of correlation to a whole other level. So in simple linear regression, we would do something like, let's see if we could predict success in graduate programs. So we would say, does success in undergraduate predict success in graduate school? So the predictor variable would be GPA in undergraduate school, and the criterion variable would be GPA in graduate school, because it's what we're trying to predict. And so this is all done using algebra, and we'll get to that later, but I just want you to get the gist of it. Now, multiple regression is when we have multiple variables predicting the criterion variable. So maybe it's not just undergraduate GPA, it's also GRE scores, and it's also writing assessment scores. So it's 3 variables predicting graduate school success with GPA. So that's multiple regression, when we have more than one predictor variable and looking at its relationship, its predictive relationship on the criterion variable. All right, so that is what I'd like you to know for the intensive about statistical tests, and I will see you soon.